Okay, a Coast Guard helicopter hovers between an island and a damaged boat. Okay, there's a boat, this island, and the island, the angle of elevation to the helicopter. So here's the helicopter, and that's 73. From the helicopter, the island and the sailboat are 40 degrees apart. So from here, if you look at these two, it's 40 degrees. And a police, okay, now it's on the water. So this is up in the air. Okay, this is, okay, I shaded in gray to represent it's like the ground, right? Here it's 35 degrees when the police is looking at the island and the boat. At the same moment, an observer from the island looks at the boat and the police in 68 degrees. Okay, so this is the diagram for it. Okay, and this is perpendicular to this plane here. Okay, ultimately we're looking for this. Okay, this distance. So I have an angle that's opposite to it. There's another angle here. So if I only knew this length here, I could find x. So let's see if we can find y. So y. Okay, there's one information I didn't write down. The 800 meters, this is 800. Okay, note that here, to find y, we have all the information we need. Y, the opposite angle of sine of 35, so we can say 35 of sine, has to equal to 800 over the opposite angle of 68, sine of 68. By sine law, we can solve for y. Once we have y, we can use sine law one more time to get the value of x. Y, I'm actually going to keep going. X over, okay, the opposite, sine of 73, will equal to y over sine of 40, again by sine law. So x is simply, okay, sine of 73 times by all of this. Okay, so 800 sine of 35 sine of 68. So I'm just going to punch this all in the calculator together now to get the value of x. The second decimal place, we get 736.28 meters for the distance from helicopter to the damaged boat.